Thank you. Can you hear me? Yes. Okay. So we're going to talk a little bit about, give you a little history lesson today about the state of open source hardware. And before we start, I'm Dustin Roberts. I'm a member of the NYC Hackerspace NYC Resistor with Katarina. We're both co-chairs of the Open Hardware Summit for this year in September. I'm a PhD student in mechanical engineering at NYU Poly, and I'm also a teacher at NYU's Interactive Telecommunications program. Katarina is also a PhD student, and we will talk to you a little bit about open source hardware and where we think this is going today.
Okay, so basically our goal here today is to talk a little bit of like what's the state of open source hardware now to get the big picture, but we also found while preparing this talk that in order to understand what's happening right now, how all these forces are converging to create this panorama, that we need to take a look at the history of how we got here. So we're going to go back about 10 years and tell you about like the emergence of the most important projects, and then at the end we would like to talk about where we go from now, and we believe that we have a few options, and at that point we really love to turn this into a discussion. Actually, we would like to keep it as dynamic and informal as possible, so at any moment please feel free to walk up to this microphone and interrupt us and give us your comments or questions, okay? So, I imagine most people here will be familiar with open source hardware. For the ones who aren't, so basically, it obviously is an adoption of the open source software principles adapted to hardware. So basically, it's a development process in which all the plans necessary to reproduce a piece of hardware are made available for anyone to study, copy, redistribute, and just basically resell and do whatever they want with those plans and that hardware. What this means is that accessibility to the hardware plans basically lowers the barrier to entry significantly. So we are seeing a lot more non-engineers and just basically amateurs from all walks of life starting to actually create new hardware or at least improve existing hardware. So we're gonna, like I said, we're gonna talk a little bit of how this all started, like back in the late 1990s. And do you wanna start, Dustin?
Sure. In the late 1990s, Linux and open source software in general was becoming really huge. And the next step was that programmers kind of turned to hardware because they figured if they had more control over the computers and the chips and the hardware they work with, they could write better software and better open source software for that. And because they'd become accustomed to kind of sharing their code, sharing the design files and the hardware files became kind of natural. And it was a natural next step. So it wasn't that open hardware started with this big fanfare and this big festival. It just kind of is something that happened naturally, and it's just what people did. One of the earliest projects that we've been able to find was Open Cores, which was a collaborative effort to develop open source IP cores, and it's one of the oldest and largest open source communities that we know of.
Another really interesting project, and also one of the earliest, is SparkFun, which those amongst you who are here today that work with hardware will so surely know. And so basically, SparkFun started in Nathan Sadel's bedroom, like college bedroom, back in 2003. And it started the way most hackers start anything, which is he couldn't find parts for his hardware, and he realized that he ordered them in larger quantities, then he could keep the ones he needed and sell the rest to his friends. So he started what he thought was going to be, like a local business, sell some parts to his friends. It took off really quickly and really well, and for recently, SparkFun announced that they had over $2 million in revenue for 2011. So it's a company that really, really grew throughout the years. And it's probably one of the, commercially speaking, one of the biggest open source hardware companies. Another one that is also really early, and so far talked a little bit about this, and so basically we're going like even further back than he did, was RepRap. And so RepRap was originally created by Adrian Boyer, who was a professor at the University of Bath in the UK. And he actually launched a project back in 2004. which is a lot earlier than we tend to think about. And so he wanted to create a machine that would allow people, especially people in regions with not that many resources, to create anything they needed, and also to create other machines to make more things. Basically, he wanted to give manufacturing power to communities that were otherwise unempowered. So he also realized two things. I exchanged some emails with him a few years ago, and he has a very interesting sense of humor. So I asked him why open source this, and he said, like, first of all, because it's a very powerful technology, and it shouldn't be in the hands of just a few, but also because if I'm, making a machine that is self-replicating, then it would be insane to make it closed source. I'll be in court the rest of my life. So basically he put out a call saying, like, I want to do this. There was a few people in my lab doing this, who wants to join us, and a handful of developers around the world, some of them software developers, began building the first personal 3D printers in their garages.
And right about the same time, or just after that, is when Make magazine started in 2005. This is the first issue cover. And it's kind of a modern-day version of Popular Mechanics and Electronics. I'm sure most of you have heard of it. And in addition to giving people the knowledge and encouragement to kind of try new things and hack what they have and create personal projects, it created a real sense of community for probably the first time. And these people were makers. They weren't just disparate groups and people tinkering in their apartments and garages. You were a maker all of a sudden. And that community force was really powerful. And they did this mostly through, who's been to a Maker Faire? Yeah. They did this mostly through Maker Faire events. And it started out in 2006 was the first one with 22,000 attendees. And now we get six-figure attendances at the San Francisco Maker Faire. There's about 4 annual ones and tons of mini Maker Fairs all across the world now. And soon after that, in Arduino in 2005, a team of researchers and educators in Italy were sitting around at a pub called Arduino and decided that they needed a better way to teach their art and design students electronics. And they just really weren't happy with any of the options out there for microcontrollers and such. So they put their own design together and they open sourced the plans. Their university was about to fail at that time, so they wanted these plans to live on no matter what happened. And they created Arduino. And since then, it's become a building block for tons of other open hardware projects. And because of its low cost, ease of use, open source software and hardware, and accessibility, it created a larger community and a larger following than any other project before the basic stamps and the other microcontroller options.
Okay, so now we arrive at MakerBot, which was one of the projects that used the Arduino as a building block. So for a while there, and still now, MakerBots are run by Arduinos. And so FAR talked a lot about that project, and we're not going to go deep into it. I just really liked the way it began. And so what happened was, by the end of the decade, by the end of the 2000s, the RepRap project was very much alive. The number of developers was growing. It was all around the world, but it was still very slow progress, and very few people were actually aware that there was an open source personal 3D printer out there. And the main reason for this, I find, and other people found, was that it was extremely hard to source the right parts, depending on where you are in the world. Like, you're told that you need Acme rod, but like, where are you going to find the right one, or good quality one? And this is a major hurdle, and one of the biggest complaints and issues people dealt with was like how to find the right parts and how to put them together, or even how to replace one part for something that was like available locally. So that's when 3 members of NYC Resistor realized that it was time to come up with a simpler 3D printer, something people could assemble without actually spending months on it. And they created the first MakerBot was the Cupcake CNC, and then shortly after that realized that if they turned that into or at the same time if they turned that into a company, then they could do what they love all the time, but also making kits available would help spread the technology faster and better. And of course, I imagine most people know the history of MakerBot right now. They've sold thousands of printers, and they're a multi-million-dollar company right now. So in the aftermath of like, or in the process with the excitement around 3D printing growing, and MakerBot was one of the companies. There was like RepRap was also growing at the same time, and they were feeding off of each other. We started seeing other projects like in similar areas appear. So now we have, as again, Far mentioned, like a lot of 3D printers, amongst them like Ultimaker, which is also open source, but also more open source digital fabrication tools. For example, LaserSaw, which is an open source laser cutter, and DIY Little CNC, which is an open source CNC mill. So, I mean, basically, we saw this landscape like grow really fast and expand in several directions.
So then if you notice on our timeline, you kind of get this exponential curve up towards the up towards now. And there's tons of companies that we could talk forever about. Adafruit, Local Motors that makes their own open source car plans. DIY Drones that makes basically robotic autonomous planes and helicopters. Beagleboard, Bug Labs, Dangerous Prototypes. Evilmed Scientist Labs, who their entire tool chain is open source from software to hardware. Liquidware Seed Studio out of China. This is not just the US, this is a global thing, and there's more and more of these companies popping up every day. Some people were trying to keep track of these companies for a while and have almost stopped that because there's just so many that are coming out every month. It's really exciting. And another exciting thing that we've seen happen very recently is that open source hardware is not just fabbing tools, it's not just 3D printers anymore, or Arduinos, it's open source heart rate sensors. On the left there's a picture of a pulse sensor that was kickstarted by a few NYU ITP grads. In the middle is a robo-cockroach. There's this neuroscience specialist, runs backyardbrains.com. It's a great thing to check out. And they basically can put some open hardware on a roach and steer it by zapping its antennas right or left. And you can listen to the brainwaves and things like that. And this is all open hardware, open electronics. And on the right, we have all kinds of new developments in the fashion technology industries, where we have a project called How to Get What You Want by Covacant. You can see some of the sensors here. There are squish sensors, pressure sensors, accelerometers, stitched potentiometers, tilt sensors made just from conductive fabric and thread. So there's many different directions this has taken. And
so now we get to hackerspace. Actually, we have to, go back a little bit and how, hackerspaces come into all this. So, I mean, the story of the hackerspaces, most of us know here in the US, actually starts in 2006 with Nick Farr. He actually went to Seabase in Berlin that year and was amazed by what he saw there. So he vowed to bring hackerspaces to the US, and the next year he organized a hacker trip called Hackers on a Plane, which is, a bunch of people from here that flew over to Berlin to check out hackerspaces. And so within just a few weeks of returning from that trip, the people on it created NYC Resistor, the one we're a member of, Noise Ridge in San Francisco, Hacktor in Philadelphia, and HackDC in Washington, D.C. And then something like really unexpected and magical happened, which is, inspired by both these new American hackerspaces and the German hackerspaces, some of which were like a decade or two old. The movement started spreading like wildfire, both through the US and Europe. So within just a few years of that, the number grew so much that by the end of last year, there were over 500 hackerspaces like throughout the world. So this is something that we found like it's unprecedented. We tried to look at like the locations, but it's like Tokyo, Shanghai, Hong Kong, Beijing, Bangalore, Saigon, Moscow, Sydney, Buenos Aires, Lagos, New Delhi, Nepal, Singapore, and just like a really, really huge number of locations. So this is also, along with the growth and expansion of open source hardware, this is like the human side of it that is extremely exciting to us. Okay, next.
And then around early 2010, there was kind of a lot of momentum in open hardware community, and there started to be some cries for kind of formalizing a little bit and trying to join together and see what is open hardware. Like, can we define it? Are there rules? Should we have a stamp? Should we have a logo? All kinds of stuff like this. What makes open hardware open? And at the time, Aya Badir was a fellow at IBEAM and also becoming a Creative Commons fellow. And she had been talking to John Webanks at Creative Commons quite a bit about how to get one of her projects called Little Bits, which was then a project and now, most recently, a company, off the ground, and what kind of protections she needed, how to protect the openness of this hardware, because there wasn't really a lot of precedence. None of these open hardware companies had ever been to court and had to defend it, so it was a very, very new space. So she orchestrated a meeting of about, I don't know, all the people you see here in this picture, 20, 25 people or so at IBEAM. That was an opening hardware workshop where John Webanks and also Thin Nguyen of the legal counsel at Creative Commons kind of talked to everybody and gave a rundown of what IP is, what the protections are, and advised attendees to determine the practices and norms instead of opting for a long and painful kind of legal recourse. So that day, there was workshops and a lot of talk about what to do with the legal stuff, what to do to define open hardware. And we argued, and there was community building in that. And one of the things that came out of it early on was the open hardware definition. At that point, it was a 0.1 definition, and it was basically what came out of that day, and then a lot of emails back and forth between the participants in that day. So you can find the current definition, which is in version 1.0 at freedomdefined.org, and that was started by Aya and the people at this opening hardware workshop.
So around the same time, also in early 2010, Alicia Gibb, who was then director of R&D at Bug Labs, an open source hardware company, started thinking that it was time to gather the community for a more in-depth discussion. Because again, up until then, it was just like all these companies and projects like growing. People would sometimes meet at conferences, but there wasn't anything organized about it. So she began organizing the first Open Hardware Summit, which happened in September 2010 and drew almost 400 people. So the summit became an annual event. We are chairing it this year, and it's growing. It's drawing an increasing number of people, and also, interestingly enough, the notion of hardware is expanding. So we started with mostly electronics, then from there we moved to 3D printing and product design, and now it includes neuroscience and all kinds of really weird stuff. So this year's is going to be in September as well.
So then the next step kind of after creating this Open Hardware Summit, Alicia Gibb took the helm and is now the president of the Open Source Hardware Association. And this was incorporated just weeks ago, really. So it's incorporated, it's in the process of becoming a nonprofit for education of the community to kind of spread the open hardware ethos and try to disseminate best practices and things like that. And one of the reasons was because even though there's a lot of companies in the open hardware space now and a lot of projects, it wasn't a good idea to kind of have the movement led by someone that had a commercial interest in it. So bringing those people all together under a kind of umbrella of a nonprofit is the way that Alicia and the people on the board have decided to move forward with kind of keeping the community together and disseminating all that work. And then Katerina put together an open source hardware participant survey. And one of the graphs from it is on the left. She's in the process of going through this data. And one reason and problem was that she expected, a couple hundred responses to this survey. Did anyone here take the Open Hardware survey? Great. And got over 2,000 responses to the survey from 70 countries. And she's got a lot of data to go through. So this is one of the graphs on the big orange bar shows the number of people who have used open source hardware in the graph. And we have data from everything from demographics to whether these people are working at companies or doing this on their own time. And we'll be getting that out through OSHWA soon, right? So then really, we're thinking that 2012 is going to become the year of maker culture, open source, and open source hardware. And all of these things kind of overlap, as you probably understand, open source hardware, hacker spaces, and digital fabricators. And it's going to be really exciting to see how all this kind of plays out. We not only have a wealth of open source hardware companies and projects, but now we're starting to have all of the open source hardware tools we need to make things between LaserSor and 3D printers and DIY CNCs. And hackerspaces provide kind of the human capital and the physical space for a lot of the people that want to practice these things to come together and collaborate on projects and companies and kick all this kind of work off.
Yeah, so basically what we have right now is this like really amazing combination of human capital, physical infrastructure, social relationships, and tools. So Dustin and I, we talk a lot about these things and we try to think about them, and we also try to step back and look at the big picture because, people in our community, including ourselves, sometimes we find ourselves like so driven to make things, to create things, to create businesses and grow businesses, to create hardware and make it better, that we don't always take the opportunity to take a step back and really think about what this all means when, as a whole. So then one of the things we thought, like, okay, so we have this really amazing situation. It feels unprecedented to us in our lifetime. It feels like something completely new and revolutionary, but has it happened before? So, we're hardware hackers, so we look into the hardware history, and we did find a very interesting parallel. Other people have pointed out this as well, is that there are really striking resemblances between what's happening right now and the development of the personal computer in the mid of the 1970s. And so I'm going to revisit that story very quickly because we think there's a lesson to be drawn from, looking at history and how things turned out. So in the early 1970s, computers were still huge mainframes that only universities and companies could afford. And even within these institutions, like only a very small group of people could actually access the computers. They were called the priesthood. So of course, hackers wanted to get their hands on computers. That's just how it goes. And for some of them could, but a lot of them couldn't. So there were a lot of people at the time thinking how they could make this possible. And the first avenue they found was through time-sharing systems, which is by creating terminals for a single mainframe and placing them in public places. They would give, the man off the street access to an incredibly expensive computer. And then, of course, only a handful, very few dreamed of dreamed of having this, started thinking about personal computers and started, putting together some electronics in their garages and dreaming of a day when they would have their own. So when the Altar came out in 1976, if I'm not mistaken, this community was just incredibly excited and couldn't believe that what they were dreaming about was finally there. And created a handful of them in the West Coast, created the famous Homebrew Computer Club. So the Homebrew Computer Club, just like hackerspaces, became this like incubator for the personal computer industry. Steve Wozniak was there, Lee Felsenstein, like all these really creative, amazing people, and they're exchanging information about how to make computers. They were bringing their boards, they were giving out, they're exchanging parts that were hard to find. Basically, they were just working together to get computers in their own home, so they could each have their own. But of course, there was also a very important business opportunity in this, and many of them started creating companies around this hardware that they were developing. So things happened really, really fast, and within 2 years, the personal computer industry went from non-existent to a $1 billion industry. Many of these people went from being hackers to becoming CEOs, and a lot of the information sharing stopped. So we are looking here also at a time when plans were shared freely, there was collaboration, there was something somewhat equivalent to a hackerspace. There was a new technology that was going to change people's lives, just as 3D printing might have. So we see like really, really striking resemblances here. But we also look back and see how this really promising collaboration and creative environment also ended up within 2 years only turned into an industry. There's like firstly competitive, highly patented, everything is a trade secret. Well, I mean, you guys are aware how the computer industry works. So, do you want to?
So, did anyone ever read Choose Your Own Adventure books when you were little? Okay, so here's where we think there's a really, really good opportunity for us here to choose our own adventure, because on the flip side of that cautionary tale is, this is an early picture of the NYC resistor hackerspace, is open source hardware is awesome. Let's all hold hands and like make things open and share and all of this work. And open source hardware does have a real opportunity to solve real world problems, from being able to print your own parts to making your own, steering your own cockroaches and things like that. The more we understand about technology and can educate non-engineers and anyone from any walk of life that wants to make their own stuff, the more the technology literacy we have as a community and as a world, and that we can make things better with. So on that, we'd like to ask you all to kind of choose your own adventure with us and discuss or ask questions about which ways you think this is going to end up.
Can you walk up to the mic? Or thank you. Just so everyone can hear you.
Hi there. Right. I'm pretty new to the idea of open source hardware, and I've got a whole bunch of great ideas and designs that are fairly well developed, but I'd like to put them out to the community wider to get their input and to make these into sort of even better designs. Where do I begin?
The internet. Yes. So I mean, the first thing you want to do is put your plans online. So we actually legitimately open source, and even if they're incomplete, you can just say they're incomplete. Yeah. And then it's easy to find the hubs where open source hardware developers gather. Like again, the Open Hardware Summit is the one physical instance where people like actually see each other face to face. But then they're all like these other places, or even just putting them up on your blog, tweeting them, and using a hashtag open source hardware will go a long way.
So a blog is probably a good place to start.
Yeah, exactly. There isn't like, we're a grassroots community, like,
Okay, great. Thank you.
Thank you. Good luck.
Thanks.
Howdy. So I've been a big fan of Thingiverse, uploading an open source physical finished thing or a design that's pretty complete. But I've found that a lot of developing good designs is about figuring out design techniques. This laser cut faceting works really well this way, or this is how you laser cut plywood to have a nice bend to it. Is there a place or hashtag or something to start finding or compiling or uploading, if I have them myself, solutions to design problems?
That's a really good question, and as a mechanical engineer by training, I've been looking for that for the last 12 years now. And I am part of a new project called alchematter.org. We're in super early alpha, but one of the things we're trying to do is capture this kind of tribal procedural knowledge of how to make things, and not just how to make one part, like you said, but putting stuff together. And that's a big learning curve and hurdle for a lot of beginners. So unfortunately, I don't have a great reference for you, rather than going through other projects that might be similar. If you're using, the teeth-shaped things to make a box with the T-nut way the MakerBot puts their laser cut pieces together, you can look at their plans and look at other projects that do that. And you kind of have to beg, borrow, and steal from different sources to kind of learn those techniques. But hopefully, if you have any ideas for better solutions, let us know.
I'd love to talk to you later.
Okay, great.
Thank you.
Do you have any advice for someone who has come up with something that seems original or maybe in a technical way obvious, and then receives letters from lawyers representing a patent troll?
You want to take that?
Yeah, well, I mean, That is something that we need to deal with in this community. It's really, really complex. So far, the community's stance has been to try and just stay out of courts and, any kind of legal battles as far as possible. So I would say, but in your case, if you actually receive those letters, ideally you should contact attorneys that are specialized in that. Like, for example, like one of the examples I would suggest is softwarefreedom.org. They do so open source. They offer open source legal advice, and actually they're also I'm sorry, they're also OSHWA's, like the Open Source Hardware Association's attorneys. We are trying to create a legal FAQ for the site so we can better support people who are in that situation. So hopefully we'll try and come up with solutions. But one thing that is really important to us, if you could get to us, is like, send us your legal questions, because that's the one thing we can't do anything about. Like, if we know exactly what questions you have, we can run them through attorneys and try and create like more or less standardized answers for it, or at least be able to point you in the right direction.
Kind of the big RMS versus Linus thing that I'm seeing show up in hardware is the non-commercial clauses in the licenses. Unlike software, hardware is a fundamentally different monster when you start talking about the fact that once someone in China picks up your source files and can manufacture them for 20% of your cost, you do kind of get cut out of it. And so the fact that a lot of the open hardware guys are doing the same religious, everything must be open and free, where a lot of us really do kind of want to say, this is open, you can see my plans, but if you want to manufacture 1 million of them, like, I kind of do want some sort of licensing on that. Is that something I kind of want to hear people talking about more, and us kind of deciding kind of what do we call it when it's open hardware, but there isn't this complete, total religious freedom to it?
Right now, in the open source hardware definition, there is an NC. You can't, NC is not part of it. You can't cut people out of commercializing your open source hardware thing. However, also in the clause, it says just because you want to cut people out of commercializing your thing does not mean that you shouldn't do it. You just aren't supposed to stamp it with the gear symbol. Any kind of sharing at any level is a great thing. If you want to share it but not let people profit from it, then that's your own choice for sure. And it's definitely been a point of a lot of arguments, or at least discussion in the community. So we don't have all this worked out yet. Maybe there's two different gear stamps, one for an NC clause and one for not, or maybe there's different ways to work through that, but it's not really a solved problem other than the 100 or so people that have agreed on this definition right now.
So also, like, I think that so far we're going on gut instinct and the experience of people who've been doing this for a few years as a commercial venture. And what they found was, like, at first they would use non-commercial licenses, and then they realized it doesn't matter, because like everything is potentially clonable. Like, so your copyright or your patents or whatever it is, they apply in your country. But there's no saying what happens in other countries. You have no control over that. So, everything can be ripped off at any moment, so whether they have a patent or not. So that's one of the lessons we all learned very quickly. And the other one is that most people, even if you can afford to file a patent, say you can, which is extremely expensive, you have to ask yourself, can you afford to defend it? Right? So at one point what happens, like most businesses who started off as like, okay, here are my plans, you can make your own, but you can't sell it, immediately quickly switched to commercial licenses because they realized there was really no point in preventing people from copying it for commercial purposes. Sorry, we can barely see.
Cool, yeah. I'm just curious for any comments surrounding things like Arduino that claim to be like open source hardware, but the microcontroller itself is closed, so it's an open platform with a closed brain. Thanks.
That's a really interesting problem that was brought up last year at the summit, right? There was someone who did a presentation last year at the Open Source Hardware Summit on open source ICs, and that's kind of the next frontier, is that it's so complicated and expensive to create ICs like that in bulk that are open and affordable to make an open hardware controller like the Arduino, that no one's really done it yet. That's not to say that people aren't trying. So if you have expertise or methods or things like that to bring up, then that's great. You're not the only one that wants that, for sure.
Hi there. I just want to kind of follow up on the Arduino concept, because the other way is going is that people are able to make and build and use those particular closed chips. And so we're starting to see Arduino-derived boards, like lots of them. And so this is an interesting example of people aren't necessarily copying those boards and then selling them, because that does happen too, but people now have a way of developing the board and saying, this is an Arduino-derived board, but now you have Arduino-derived boards that are like PIC32 or the ARM Cortex. So we actually are about to see many different kinds of boards that are Arduino compatible, at least in terms of the API. So we have a thing now where it's not just being like a clone or something, we have derivations and multiples. So I think it's like a living example of, you know, this diversity suddenly showing up. And how do people respond? And I guess Arduino decided to go a trademark route. You know, so I'm wondering about is that an option for other people, or parallels or thoughts you have?
Yes, of course, you're absolutely right. We actually failed to mention what's one of the biggest advantages of open source hardware is that most people will not clone your work. They will make a derivative, or they will make hardware is compatible with it. And that's the case with Arduino, like the poster child for this, in the sense that there are, I believe, hundreds of Arduino derivatives, meaning boards that are not an exact Arduino, but they just have a different function. One has like Ethernet on board, and the other one is just made to water your plants or something. And there are also hundreds of shields for Arduino, meaning boards that extend the Arduino capabilities. So that increases the value of the Arduino itself, because the more hardware you can interface it with, the more valuable the board itself is. So this is a major, major advantage of open source hardware. So in terms of your question about trademarks, so trademarks, the open source community is a little averse to any kind of intellectual property and having to deal with lawyers and, cease and desist and that kind of things. But I actually believe that trademarks are important, and, people are going to have different opinions. And because I try to think of it this way, say someone used my name or my photo in something that I really, really don't agree with, something that I found outrageous or really, really harmful. I would not want that. So I think companies think in the same terms. For example, you don't want, I can completely understand that there are clones out of Taiwan, Arduino clones that don't work. They simply don't work. You buy the board and it does nothing. And if they actually had the Arduino name on it, that would be really harmful for the company. Also, it's a way to protect your customers, because then they know that they're buying something that you made and that they can go to you for any problems. If they buy a clone that has your stamp on it, then there's no saying, how that's going to end, or if you even protect or have customer service or anything. So it really protects everyone. Just try to think of it in terms of would you want someone to use your name on something that you didn't do?
One thing that came up last year at the Open Hardware Summit when Arduino gave the keynote was that they don't necessarily like it when people name their project something Duino. That's not original, they said. And so just because you used not the first two letters of Arduino doesn't mean that you didn't kind of copy that name. So when they encourage any kind of hardware derivatives and shields and all that to say something like Arduino compatible, but don't call it the new Duino or something like that.
Howdy. One of the questions I have is, half the problem is designing PCB layouts with open source hardware. What resources exist for discussing open source or otherwise non-commercial software for hobbyist developers? Obviously, there's a plethora of commercial packages, but they cost a substantial amount of money. And for somebody on a hobbyist budget, it might not be feasible. And some of the open source packages will range of different qualities. And it's kind of hard to get a total overview without really finding either a forum or a wiki that just lists all the packages and their different experiences with people.
Do you mean software packages, like design tools?
Yes.
Okay. Well, one of the ones that I see all the time, and I'm a mechanical engineer by training, so I don't use it often, is Eagle. Because Eagle's version that's free is you can design boards up to, I think, 4 inches by 3 inches, single layer, and tons of people have used that to start companies. Adafruit started that way, SparkFun started that way, Arduino used that, and then they still use that. So I've even seen early prototypes of Adafruit boards before they bought the pro version of Eagle, stringing together with ribbon cable boards that are 4x3 and 4x3 and 4x3 because they could get those, they could design those for free. So the next steps up, there's lots of different, there's Eagle Pro, there's Altium Designer, there's lots of different really expensive, a whole range of software tools. But then there's KiCad is a newer one, which is a totally open source.
Fritzing.
Free PCB, yeah, Fritzing. There's is another one, fritzing.org has their own breadboard visual router that will also do schematics and board layouts too. So there's new players in this space, and you can definitely make things without paying a ton of money for software.
It would be nice if there was a forum or something available that all the pros and cons could be discussed about the different packages. This way, it's not just by word of mouth or various sources. If there's just one place for everybody to discuss that sort of software.
So yeah, I mean, first of all, thank you for the suggestion, because this is like something that we now know we need to think of, for example, for OSHWA, which is to try and make that information available, because we thought everyone would know, but of course it's not true. The other thing I find interesting here is that this is one of the fundamental differences between the open source software and hardware communities, is that open source software is collaborative by nature. So you have, hundreds, thousands of people working towards the same project at the same time. And in open source hardware, because it's made of atoms, that doesn't happen. So open source hardware is iterative, it's derivative. Like you make your board, someone else builds on it, someone else builds on it, but not everyone is working towards one release. So that's probably why we're not as good at creating packages and thinking in those terms. But I guess we should take a cue from the open source software community and start thinking more in those terms.
Actually, playing a bit off of what you just said about the hardware being more derivative, I was involved over the past couple years in a couple projects I was working with a couple of friends of mine, and one of the things that actually came up that a couple times was just the supply line. One of the things that we were interested in, like you have a lot of New York City resistors spawned the whole Mendel and the whole RepRap stuff, and that was great, and I have a lot of people working on it. And a lot of the items particularly use similar parts, like taking what you said earlier, Acme threaded rods are a very common thing for the control lines in those. One of the things I was just thinking, has any thought been given to exclusivity of advertising rights or anything along those lines? Like, for example, MasterCard is a big seller that we buy a lot of things from in the New Jersey area. Perhaps if the RepRap community were to at least advertise, like, maybe try to sign a deal with a company whereby they can lower the prices of parts by offering exclusivity advertising on certain websites or other things along those lines, or in another kind of way, trying to bring it down by offering bulk purchases, like 10 people building RepRaps across the country come together and puts together an order for all their parts in at the same time, thereby trying to hit the threshold marks for bulk quantity, which brings down the cost. I'm just trying to, it's like you did say a second ago, I mean, hardware is atoms, and a lot of the minimum boundary there is, unfortunately, money. It's how much can you afford to do. So I'm just trying to now actually think about in terms of finances, is there ways of doing these kind of methods to try to bring down the floor on the cost?
Hello? Yeah. One thing is that the cost of assembling people together to do something like that is almost zero now. I mean, you can start a meetup from anywhere, meetup.com from anywhere in the world, even if you don't have a local hackerspace, to kind of get people together to do a joint purchase like that. But also, hackerspaces are also a great place to find, like-minded people or friends of friends of them that are like-minded people to do a bulk order like that. But I think that as far as like talking to McMaster and stuff like that to get discounts, that our community is just not big enough to make it worthwhile for them to offer a discount on 400 steel rods or something like that. Whereas you do get bulk discounts anyway when you buy 400 versus one. Usually on McMaster, there'll be a price break at 10 or 100 or something like that. So it may be up to us at this point still to assemble enough people to get those price breaks. But I would love it if there was a hackerspace checkbox on the McMaster checkout form that you could assemble a bunch of groups together and do it. And in the electronics fabrication, they're already doing that. There's what is it, Batch PCB that grew out of SparkFun, right? And there's a PCB service that grew out of the Pittsburgh Dorkbot community, where he basically was doing the same thing. Like he'll accumulate designs until he's got enough for a panel, and then send it all out at once. So you might have to wait 2 or 3 weeks for your design to get back to you, but it'll be way cheaper than just ordering it from Advanced Circuits or something. So I haven't seen someone offer a service like that for hardware parts yet, and you might be able to start that and say, look, when I get an order, enough people interested in 100 steel rods or whatever, I'll buy them, and then I'll send them to you. But no, I haven't seen that yet.
Hi. I was just coming up in regards to the question 2 questions ago. I'm actually giving a talk here tomorrow night at 9, designing free hardware. And it's in particularly about using free and open source tools to build from start to finish your hardware and get it produced and everything that goes with that. So, and I actually compare some of the different tools that are available. And you missed JITA. JITA is the best.
What is JITA for? I don't know that one.
It's GPL, Electronic Design Automation. It's by far, I think, the best free software tool for designing PCBs.
That's awesome.
Very awesome.
Can we ask you? We'll first ask everyone to go to his talk, and second,
Yes.
if you can publish your slides anywhere or
Yes, they
anything
will
you
be
use,
published.
that would be awesome. And let us know.
No problem.
Oh, one more question, which is, I know that you work with robots and all of that. So basically, there's a lot of open source learning robotic platforms all coming out, and the small STEM bots and all that. So you think that's an area in terms of open source that there's still more opportunity, or is it an area that there's a lot of competition in, or it's getting locked into? So I'm just wondering, in terms of like open source, everyone can do something, but trying to compete for everybody's attention for your open source bot is tricky.
Yeah, I guess it's kind of a catch-22. Is like you kind of want more players in the market, so you get this kind of natural evolution that Farah was talking about, where the larger ecosystem, the different players, the better. But I also, since I am in school still, I see a lot of the teaching tools are still very closed. They'll cost thousands of dollars to get like a MATLAB and robotic arm setup from some company that specializes in that, and it's very closed, and it's not something any student would ever be able to replicate on their own without thousands and thousands of dollars. So lower cost educational kits, not just for college labs that might have the money for the expensive stuff, but also at the high school and middle school, pre-engineering level, summer camps, stuff like that. I think there's definitely a big opportunity there for robotics types kits. And I'm teaching a class this August in Third Ward about building a robotic arm, and I had to make my own kit for it because the only ones that were available are $800, and I can't charge that for a 2-session class. So it'll be interesting to see, and that's an Arduino derivative, kit that we're trying to work out. So if you have ideas about how to work that into the community and who to talk to about that, I'd love to hear them too. Okay.
No more questions? Okay, well, thank you so much for, listening and for your contributions and questions, and we'll be around. We want to continue the discussion.
We'll see you at the summit. Right?